So apparently I did not finish the last video, so here's a little addendum to add to that. It ended when I was going to discuss what to do with the cholesterol reading, so it's nice to actually have a fresh screen. So looking at the cholesterol, right, we can see it right here. You can see the absorbance values and things like that. And we'll do the same thing we did for the glucose. We know the concentration of X, that's what C of X means down here, right? That's the concentration, X would be the unknown. We need to know the concentration of the standard, okay? So we can find that off the table right here. So notice that's 200, so that goes there. I need to know the absorbance of the unknown. Here's our unknown, 0.35. That goes there. And then we need to know the absorbance of the standard. We can see that from the table at 0.38. So I find it easier to do the fractions first, although it doesn't matter mathematically. So 0.35, the absorbance of X, divided by 0.38, the absorbance of the standard, right, times 200 milligrams per deciliter, and that equals 184.2 concentration for the unknown. So that falls right in the normal range. Remember, the normal range is 130 to 250. And if we wanted to do what the normal serum was, you would do 0.41, and you would replace the 0.35 with that. So you get 0.41 over 0.38, which would be, about 215 or so, probably, is guessing. 0.41 divided by 0.38 times 200, equals 215.8. And then you could do the abnormal, which is 0.21, which would be, like 120 or something. So you could do that. Now, the protein is kind of where we're going to do it a little bit differently. All right, so for protein, I want to erase that. So for protein, the issue we have is that we use the same formula, but notice for protein, right, we have multiple numbers. We have multiple standards. And so let's kind of go back and just kind of look at our standards really quickly for the other two. So glucose standard, right, was 100 milligrams per deciliter. We use 100 milligrams per deciliter for glucose because it's pretty close to what we expect glucose to be. Most people, for fasting glucose, are going to be 70 to 100. So 100 is a nice, easy number. What about cholesterol? Well, cholesterol, we said the range was 130 to 250. Most people are actually in the 200s. I think the last average I've seen in the U.S. of everybody in the U.S. is about 217 or something. So 200 is pretty close to what we expect. Well, when we come down here, right, you say, okay, I'm going to do plasma. I could theoretically use any one of these standards, right? But we want to use something that's close to physiological values. And so when I look, I go, okay, well, the norm for protein is 6 to 8 grams per deciliter, right? Actually 6 to 8.4, I think the current Fox book says now. And so you'd think, okay, I want to use 6 to 8. But if you look at the data does something a little odd. Notice the concentration goes from 0 to 2 to 4 to 6 to 8 to 10. So it goes up 2 grams per deciliter units the whole time. And if we look at the absorbance values, it goes from 0 to 0.07. All right. Goes up again, 0.14. Goes up again, 0.21. Goes up again, 0.32. Well, you would expect if it followed this pattern, it would be 0.28, and then standard 5 is 0.35. That falls right in line with the other values. So when you look at this data, you think, oh, you know what? 8 is probably an outlier. Something's wrong with 8. Yeah, it's theoretically possible that this is the only right one and all the other numbers fall perfectly on a straight line, but not very likely. So I would say, okay, it looks like this standard, which should be, if it follows the pattern, 0.28 is actually 0.32. I wouldn't use the standard 4, right? because it looks like it's wrong. So why would you use something that's wrong? So if we're looking for a standard that's 6 to 8 grams per deciliter, and we know we're pretty confident the 8 is bad, then we wouldn't use that and we would use the 6. So I'll use the 6 for this one. So again, we're not going to use the 8 because it's wrong. So I'll use the 6. Right? So that concentration would go here, concentration of the standard. I would use the concentration of the unknown, 0.22. Right? That would go my AX. And then the absorbance value associated with that concentration, 0.21, would go on the bottom. Right? So you would get 0.22 divided by 0.21 times, we're going to use the concentration of the standard 6, and that's going to equal 6.3. So that would give us 6.3 grams per deciliter using those values. So again, you just, same thing, you just pick whatever standard you want to use. It makes sense to use the one that's most physiological, that is correct, which is for our data, standard 3. So you use the concentration of the standard, which is 6, right? You put that here. We use the absorbance of the unknown, that's 0.22, I got that from the table. And then 0.21 is the absorbance of the standard we put on the bottom, put that through, and that's the math. So that's how you do the other ones and how you pick the various numbers when you're looking at protein. One other thing, erase that. And we'll move on to the next slide, hopefully. Now, we're not going to worry about a standard curve for exam purposes, so I'm not going to go over it, but this is what a standard curve looks like if you were to plot the standards and things like that. And then you could use this standard curve to figure out what the concentration would be. So as an example, if you want to know what something like a 0.4 absorbance is, you take the 0.4 and go over to the line and then go this down. It would be right around 12 would be the protein for that. So we're not going to worry about the standard curve, though, for exam purposes, so don't worry about that one. So that was it, a little addendum on how to do the other two calculations.